Welcome everyone. Hello everyone. We hope you had a great time this week, but the conference now comes to an end. And with this last session, we can conclude EuroVis 2021. So let's get started with the capstone talk and then following up with the closing remarks for EuroVis 2021. And for the capstone talk, this is the last big highlight of EuroVis 2021. The capstone talk which will be given by Yvonne Rogers, Professor of Interaction Design at the University College of London. And moderating the capstone talk will be Rita Borgo on behalf of the full paper chairs. So I will hand over to Rita for the final introduction of the talk and the speaker.
Thank you, Renato, and good afternoon, everyone. Welcome to the capstone session. My name is Rita Borgo, and on behalf of the full paper chairs, Liz Marai, Tatiana Vollandersberger, and myself, I have the pleasure to introduce and welcome our capstone speaker, Professor Yvonne Rogers. We are honored that Professor Rogers has accepted our invitation. And in this introduction, I can only barely touch on describing her career and many achievements. Yvonne Rogers is the director of the Interaction Center at University College London, a professor of interaction design, and the deputy head of the computer science department at University College London. Her former positions include professorships at the Open University, Indiana University, Sussex University, and she has also been visiting professor at University Cape Town, University of Melbourne, Queensland University of Technology, Stanford University, Apple, and University of California, San Diego. She is internationally renowned for her work in human-computer interaction, interaction design, and ubiquitous computing. Her current focus is on human data interaction, and in particular, human-centered AI. She is a fellow of the ACM, BCS, and the ACM CRI Academy. She was awarded a Microsoft Research Outstanding Collaborator Awards in 2016 and a prestigious EPSRC Dream Fellowship to rethink the relationship between aging, computing, and creativity. She's passionate about designing interactive technologies that augment humans and that are at the same time engaging, exciting, and even provocative. She has published over 250 articles and is co-author of the textbook on interaction design that has sold over 200,000 copies worldwide and has been translated in 6 languages. I personally, myself, owe Professor Rogers a debt of gratitude, as in my first lectureship position, I was tasked with teaching a human-computer interaction module, and I must say that her book was a godsend and played a major role in the delivery of a module, which was way more successful than I could have ever expected. Professor Rogers is also the curator of a very interesting blog named Interactive Ingredients, which has a lot of interesting viewpoints, a lot of articles and blue sky and inspiring out-of-the-box ideas. But without further ado, let us welcome Professor Yvonne Rogers and her captivating capstone talk, Slowing Down How We Think with Visualizations.
Thank you very much, Rita, for your very kind and generous introduction. And I'm glad you found our textbook to be inspiring and useful in your teaching. I hope you've all been having a great conference. I had a look through the program, and there seems to be some really interesting papers and other keynotes that have been presented. So in my capstone, I'm going to finish with, as is my wont, something slightly provocative, which is to think about how we might design data visualizations and data analytic tools differently to what is the norm. And my idea is to think about how we might slow people down when they're using these tools, which might seem counterintuitive, because when we design software, we're trying to improve people's cognition and make them more efficient and to speed up how they perform and complete tasks. So why would we want to slow down how we get people to think about data and visualizations? Well, I'm going to start by thinking about two everyday examples where it might make more sense if we slow down rather than just be sort of rather quick and rather regretful in our decisions. And so two of the everyday examples I'm going to mention are when you try and stop a user in their tracks before making a rash decision, and maybe secondly, playing a more challenging video game. So firstly, I'm sure you've all received that email that makes you cross and angry. Someone has written something that isn't what was said in a meeting or accuses you of something, and you just sit there and you reply immediately, bashing away at the keyboards, and then you press that send, and then you regret it because it will just escalate. So sometimes it might be better if you didn't send it, but you slept on it, and then the next day you change the tone of your reply such that it doesn't have that effect on other people. So there's an example where we've all done that and we regret it, but if we just slowed down and thought about it, we might not have got into that situation. Another example is when you forward on some news or a link to others. This can be in Facebook or other social media without reading it. And it might be fake news. It might be something that you perhaps shouldn't be forwarding on. And so Facebook has developed this pop-up message that it says, perhaps you would like to think before sending this link. So it says you're about to share this article without opening it. And the idea here is to just stop the user in their tracks and think a bit before forwarding it on, and maybe just reading it first. So those are some examples of where just stopping you to think about it might help. Another everyday example where slowing the user down could be beneficial, but again, counterintuitive, is playing video games. So here's one that's a retro video game called Vesper 5. And the idea here is to encourage the user to reflect on playing. And so they might take one step at a time. I'm going to play this video and hopefully it'll work and you'll be able to see what this slow game is.
Hey guys, it's Icy New Year. And I'm here with a rather unusual game. It's called Vesper 0.5. I'm going to read the readme that came with it, the what is this.txt. Vesper 0.5, made for a super friendship club pageant with the theme ritual. In this game, you may take one step each day, and then you must wait for the next day. If you wish to complete the game, you'll have to make it a part of your life for at least 100 days. Make a ritual out of it. How will you incorporate it into your daily schedule? How will you tie it in? Will you tie it to an existing activity? Will you treat it as a ritual or merely a routine? Will you add to the ritual, embellishing it in your own way, making it yours? Meditate, say a prayer, think back over what has happened while you're playing. Will you approach it alone or share it with another? Is it worthwhile? You'll have to answer that for yourself.
So that's an example of a game where it's getting you to think about how you might fit it into your routines and how you might play it. Very different from normal game design, which is to design it for speed and efficiency and to get to achieve certain goals as fast as possible. Another game that's been designed is Will Odom, who's an HCI researcher, and his game is called Slow Game. And the idea here is you play it, again, very slowly. You do one move a day using these very aesthetic, tangible cubes. And the idea is it allows you to reflect and to observe and to be patient. And it's based on the snake game, which I'm sure you've all played on your smartphone, where you have to make your snake move around, get longer, but avoid obstacles, particularly its tail. So here, the LED lights represent the snake, and you just move it for one day, and then you wait to the next day. And here it gets you to think about your moves previously in a much slower way, and also to think about what you might do next. So there's two examples of everyday activities where you can slow down and you can get different experiences for the user. But for most types of computer tasks, the aim is to make them as fast as possible. So why would we want to slow them down? And if we look at some of the dashboards that have been designed, they're all about optimizing user performance. And here you see one where you can see at a glance different visualizations or different graphs of data, and that allows the user to see and compare and to do this in an optimal way. If you were to just show one of these and they would have to click through, that might make it more difficult and slow them down and not optimize it. Same with many data analytics software tools. They're designed for efficiency. So this is the blurb on one website that I found for a data analytics tool. Effortlessly changes visualizations, chart types, widget sizes, table formats, filters and multiple other parameters to build truly impactful reports. So again, it's just echoing that, you know, efficiency is about speed and making things effortless. And many GUIs have been designed to support fast thinking. And examples are, you know, the use of filters and menus and pop-up boxes. And the reason is, again, to make tasks easier, but also to reduce errors and make them more efficient. And here's an example of some software which is capitalizing on GUI features to make the selection of certain dimensions and options really easy. You can type into a search box and you can select from a menu and it will change the parameters and dimensions. You can have different types of graphs and it makes it really easy to explore data. But so I've shown you how you know, selecting and changing is best done through supporting you know, efficient ways of carrying out tasks. But what about sense making? Might it be better not to be always fast and efficient, where you might slow someone down and encourage different ways of interpreting data? And here on the right is a topical graph of what happens after people have two vaccinations for COVID. And this is a graph for Israel, which was a country that was ahead of most other countries in giving vaccinations to its population. And here you might want to think about, you know, what's the impact been after one, after second dose, and in particular, the type of vaccine that was given and how many people contracted it and so on. So there are many ways in which you might want to interpret the data and think about its consequences. And arguably, it's when you're doing this type of sense making that it becomes important to perhaps think in a more slowed down way. So let's, you know, think about how might we design software and when to encourage a different type of slower thinking. And many of you might be aware of the book that came out 10 years ago, which was a bestseller called Thinking Fast and Slow, which was written by Daniel Kahneman, who was a Nobel Prize winner. And in this book, he describes two systems. One is known as System 1 and involves fast thinking. And by fast thinking, this is where you act on instinct. It's automatic and often emotionally charged. And, you know, one of the things about fast thinking is that it allows you to focus on one particular thing and it excels at integrating information about that one thing. So, for example, we might say, you know, we make assumptions and claims about things. For example, all computer scientists are geeks, or computer science are all geeks, depending on how you think about these things. And it can detect simple relations like they're all alike. But some of the cons of this way of thinking, this fast thinking, is that it can be prone to bias and errors and blindness. Some of you might have seen that video where participants are asked to watch and count the number of times two basketball players pass a ball to each other. So whilst they're focusing on the number of times the ball passes around, what appears is someone, an actor who's dressed up as a gorilla, who walks past and slowly looks at them and then takes off out of the video. When participants are asked, had they seen a gorilla, most of them say no. And the reason is that they're focused on counting the number of times the ball is passed between the players. And this can happen in all sorts of tasks where we might be prone to making errors, to jumping to conclusions. Fast thinking is also impulsive. It's really hard to stop yourself from thinking fast, and it can't be switched off automatically. Also, it's really hard to deal with multiple distinct topics at once. Whereas slow thinking, one of the benefits of it is it tries to monitor and control our thoughts and actions that are proposed or suggested by System 1. And what it tries to do also is to construct thoughts in an orderly series of steps, so being more thorough in how it gets to a conclusion. And in doing so, it enables better decisions to be made. The trouble, though, is that it can be more demanding to think slowly, and it takes more effort. And in doing so, it requires more discipline. We have to be much more methodical and take those steps. And when we are thinking more slowly, it can be disrupted when our attention is drawn away, and it can be quite difficult to get back. So how do we know whether we are involved in fast or slow thinking? Well, there have been various tests developed in order to try and determine what people are doing for various tasks. And perhaps the most well-known that was devised by Shane Frederick is what's called the cognition reflection test. And many of you may have tried this, but it might be a while since you did this. So I wanted to see whether or not you use your fast thinking to answer this. So a bat and a ball cost $1.10. The bat costs $1 more than the ball. How much does the ball cost in cents? Well, most people, including many students at Harvard and Yale, will say 10 cents, but that is wrong. So 10, and why do they come to this conclusion? They jump to the conclusion because they don't read the statement slowly. They read it as a bat and ball costs $1.10, the bat costs $1, therefore the ball must cost 10 cents because they add $1 with 10. But if you read it correctly, what is missing from that is it's saying if the bat is $1 more than the ball, it makes the bat $1.10, and therefore the total would be $1.20. So as you probably have worked out, that the correct answer is 5 cents. So if the ball costs 5 cents, the bat costs $1.05, and the total for the two is $1.10. So if you read this more slowly and use your slow thinking, it doesn't take that much to work out that the correct answer is 5 cents. And yet, thousands of people have been tested on this, and over half, sometimes many more, come up with the wrong answer because they jump to the conclusion and misread it. And that's based on fast thinking. So I've given you a quick overview of some of the key ideas that Kahneman has proposed for fast and slow thinking, and one of the tests that are used. And I've also given you an overview of some of the software tools that have been designed for data analytics and visualizations. And most of them are designed to encourage fast thinking. And there's nothing wrong with that. That's important that I make that point. But sometimes designing for slow thinking has the potential to enhance ideation or problem solving or more deep sense making or meaning making. And so the question I want to put to you, and one that I am interested in, is how and when should designers try and design the interface to promote slower thinking? Well, you need to not look too far, because within human-computer interaction, there is a very well-known consultancy group called NNG, and that is the Nielsen-Norman Group. And they have been writing blogs and articles and providing courses on UX and UI. And last year, they wrote an article about slow UI. And it was all about how we can pace interaction to increase understanding. And so they use a number of examples, but one I think illustrates really well how you can design the user interface to slow users down is for e-commerce. So during the pandemic, many of us have resorted to shopping online, and in particular for clothing. And there are many of these sites out there. And the way in which they're designed is they'll show an image of the clothing, and then they'll have drop-down menus for you to select the color of the item and the size. And what Nielsen and Norman point out is that many people may select the wrong color or the wrong size. And this can be, costly to the company, but also time-consuming for the consumer. So here again, when you select the size, you can just go down the menu for your size and accidentally click on the wrong size. And so what happens as a consequence, and many of you may have been through this, is that you have to send it back, return it, and have to wait in a line at the post office in order to do this. And so this is very time consuming and also very costly. So how might we design the interface to reduce these types of errors? Well, this is where Norman and Nielsen have proposed coming up with a new widget at the interface that will slow users down and reduce errors. So rather than having a drop-down menu, what they're suggesting is to have this widget here, which is a color picker. And you can select the color of your t-shirt. Now, this might seem straightforward, and it is. So here you are. You're all familiar with these color pickers, and you think, I'd like to have a green one. So you click on here, saying a lime green, and this is what comes back. Sorry, this color is not available. Please pick another. So what you have to do is to try and find the color that they have t-shirts in. And this can take you, try again. So we'll click here, and it says, sorry, that color is not available. Please pick another. And it will really slow you down. It could take 2 or it could take 100 times before you get to that right color. But at least you know it's the color you want, and it's one that the company have available. Now, what about the size? Well, they thought about this, about how could they slow people down so they don't make those errors in selecting the wrong size. And the way in which they've done this is to have a button here, which is called inflate. And you click on this and it will increase the size of the t-shirt here to what you might think is your right size. So you keep clicking on this button and then it gets to a size you think is yours. If it gets too large, you then use this pin here and that will deflate it to the smallest size and you start again. So you can keep doing this, slowing down till you get to exactly the size you want and you know that's it. So the conclusion with these two widgets is that slower is better. And they argue that if we can use these types of widgets, then slow user interfaces have the potential to reduce e-commerce return rates from 92% to a much smaller number. In fact, the slower we make the UI, the fewer orders will be returned. Now, you might be thinking, that is weird. I have never seen anything like that before. Surely that will just frustrate the users. It will cause them no end of grief. And you are right, because it wasn't a real article. It was an April Fool's joke that they do every year. But it fooled me and many others because we like the concept of slow UI, but that was just taking it too far. It was taking, as we say in English, the biscuit. But anyway, I'd like to thank Jakob Nielsen for a wonderful joke. But it does make you think, how can we slow down users in a way that isn't going to be frustrating or annoying, but could help to facilitate particular cognitive activities that we'd like to encourage. And one way in which people have started to think about this is in terms of designing not the sort of filter interface I showed you where you just select options or deselect, but to use chatbots. And chatbots, as you know, in the last 2 or 3 years have become very popular as a way of asking questions for different types of commerce or for banks. If you want to know about a particular mortgage or insurance, you type in your question and the chatbot, which is an AI agent, can answer and direct you in the way in which gets you more quickly to the service you require. So one of the benefits of using chatbots is it can enable users to ask questions specifically about the data and get them to think about what they really want to find out. And about 2 years ago, Tableau, which I'm sure you're all familiar with, introduced or added to their data analytics tool this Ask Data functionality. And I'm going to play the video again to illustrate how effective it can be to have this type of chatbot at the interface.
You need answers? Ask your data. No, seriously, just ask your data. It's pretty easy, really, and everyone can do it. He can ask it to help find new opportunities, or he can ask it to check out the competition. You can ask pretty much anything. Okay, not that. Well, maybe that. She can ask it to evaluate market positioning. And he can ask it to help figure out if it's going to be a great vintage. You can even ask it how to bring in the professionals. So, any questions? Ask Data, answers for everyone. From Tableau.
So what you saw there is how the data has been designed, the application has been designed whereby users can ask questions. And my own research has been concerned with how we might design these types of chatbots, not to just get users to ask questions, but also to think about how the agent might ask users questions in order to get them to switch from their fast thinking to slower thinking when conducting various types of data analytic tasks. And our rationale or our motivation here is to enhance particular kinds of open-ended sense-making and brainstorming where it can be difficult to know what to do with the data or what it means. And in particular, not just for individual users, but to encourage more discussion in teams when doing this. And so what we've been looking at is how can we design agents that are proactive, that take the initiative to ask questions of the user at the interface or to prompt them. And how might they do that? Well, we can use voice-based agents like Alexa, where you talk to it and it talks back to you or it asks you questions, or we can use GUI text-based input and output like chatbots. So we're interested in these two aspects. And one of the projects I've been working on, looking at these two, is called the VoiceVis project. And this is with Leon Reichertz. And one of our first publications was last year, which was Do Make Me Think. And as I said, what we're trying to do is encourage more human discussion, particularly in groups, and to enable, the context was to enable teams of clinicians to make better decisions by helping them interpret and analyze health data. And the two research questions that drive our research are, firstly, does providing a proactive agent slow down users' thinking? And secondly, does the way users interact with the agent at the interface make a difference, i.e. if they're talking with the agent or are they typing at the agent? So the first research question, can a proactive voice assistant slow down thinking? So we designed an agent, Visi, to be able to respond to team member requests to present data visualizations on a shared display. So they could just say, show me this, show me that. But we also got Visi to prompt team members to try out different ways of thinking when considered an opportune moment to do so. So it could both respond to the participants, but also to ask them questions. And examples of the questions that Visi can ask were meant to be ones that probed and prompted rather than yes, no answers. So examples included, do you need a hint for analyzing X? What do you think of this? Shall we move on? Did you consider the difference between variable X and Y? What might have caused a sudden spike? So these are meant to just trigger getting them to think, or to focus on a particular aspect of the data that they may not have thought about or have overlooked. So our setup was to have these teams of clinicians be able to refer to a shared display, which is the interactive data visualizations, and to be able to talk to each other, but also to talk to the agent through this speaker here, and to discuss what the data visualizations mean, and for Visi to be able to make suggestions or to probe them when they appeared to be stuck or they were going down a different track. So the data sets that we used in our studies was to take some existing data that's out there in the public domain, looking at the very alarming trends in obesity over the last 30 years, and to think about why is there these patterns that are happening in obesity? Why is it on the increase for different demographics? So we looked at male and female data, also young and older people, and developing and developed countries, and to try and get them to work out why there was some straight line, some on the increase, and then some flattening. So, even though it's only 3 variables, it was quite complex for them to think about. And we didn't actually build our agent to begin with because we wanted to manipulate the conditions. So we used what's known as the Wizard of Oz method. And this is where you have a human being on the right. Here is Ethan, who is pretending to be the agent and to be able to intervene at opportune times. So on the left here is the setup for the experiment where we had pairs of participants interacting with Visi via the speaker and the microphone here, and the data visualizations being displayed here. And this was the agent who would click on a key to trigger what the Visi might say, either as speech or as text. So we thought a lot about the criteria we might use for when Visi might intervene, and we thought just keep it simple to begin with. So if there's a silence in the conversation for at least 3 seconds, that's when our Visi here would click on one of the possible questions that were available. And then secondly, if participants haven't previously discussed a topic directly related to that question, then they might also intervene. So what we didn't want to do was to design an agent that was always intervening and getting on their nerves or disrupting the flow of the conversation. So it had to be done sparingly. So that was research question 1. Research question 2 was to compare the effects of interface type on team performance. So we had 2 conditions, voice or text. So in voice, participants voice their commands or ask Visi to show certain visualizations. And Visi will ask them questions by speaking via the speaker. Whereas text, it was participants use a screen-based menu to select the commands for Visi, and Visi asked them questions through a chatbot message. So our hypothesis, based on the literature, was that voice will encourage more interactions with the software tool, and also more of the available data visualizations will be looked at. So in our experimental design, we asked 16 pairs to make sense of a series of those data visualizations about obesity levels for the last 30 years for those 3 dimensions. So just to summarize, here's the voice condition. The user speaks out the requests to generate the visualizations, which might appear here. So they might say, show me obesity levels for developed and developing countries for women and men, or for boys and men. And our system will generate those. And then the prompts that Visi give are, why is the difference between women and men larger? So that's the voice condition. The text condition is the same, except they have a tablet here where it appears they can select the options using a filter window. And then Visi will respond or prompt them by using this kind of chatbot window here, and it will describe or it will ask the prompts in that way. So what did we find? So let's go back to question 1. How effective was Visi at slowing down thinking? Well, we asked the participants afterwards, after they did the task, and many of them said that it helped them to think about the data sets from a different perspectives than if they hadn't been prompted. And it also made them do the analysis task more slowly. It helped them to not get lost or to get stuck on a particular data visualization. It got them to think about other visualizations that they could generate. And importantly, it helped them to better understand and remember certain aspects of the data. So it made them think, oh, let's just go back and look at those two and see how connected they are with these. So it helped, if you like, to give a scaffold to the way in which they move through the different data sets and try to reason with them. And here is a quote from one of the participants who was talking about how it helped them to see different. And it says, I like the way the questions were, oops, I've got that in, on finding out more about the data. By answering the question or even by looking at it, you would think about the consequences. And then you would ask yourself, why is this line more steady than the other? This just wouldn't happen necessarily without the aid of the assistant. So you can see there how the participants were aware of what Visi was doing and their role in helping them to structure and to scaffold. They were also aware that Visi wasn't there to do everything. Visi was there to get them to think. They also pointed out that perhaps it's best used for certain times during a task or for certain tasks, that they wouldn't want to be having Visi always prompting and probing them. And here, one participant said, I guess this is more suitable if you're introducing a new topic or if you're trying to get a new perspective on the same data. So I think it was revealing to, to think about when is it appropriate, when is it suitable, and when is it not appropriate. So back to question 2, does talking or texting with Visi make a difference? And the reason we ask this is that there are the choices. We can either have it as voice or you can have it as text, and there may be differences. And indeed, we found differences between the two conditions. So those in the voice condition explored the data more thoroughly, and this was indicated by more in-depth discussions and identification of trends in that data. They spent more time looking at more of the visualizations, so they were more systematic, and participants quickly started exploring possible ideas by talking out aloud and bouncing off ideas from each other. So that was quite distinct in the voice condition. In the text condition, what we found was that sometimes the participants missed patterns and trends that were noticed in the voice condition, and that the discussion was slowed down more, because what they had to do is when Visi came up with a prompt or a question that appeared on the screen, they had to both stop what they were talking about and read it together. And then after that, it took some time to get the conversation going again. So it was, in some ways, it was more disruptive, but they were able to continue with a conversation and then decide to stop to read it. Whereas when the voice one, they had to stop what they were saying and listen, because it was, it was just said then. So also in the text condition, what we found was that participants discussed more about what the prompt meant, what was the question asking, and how to answer it. So they were focused on what it was meaning rather than in the voice condition. So you can see that there are differences between whether you use voice or whether you use text. What we also found was that they found that one of the biggest advantages is that when using voice, that they're both in control, whereas in a typical laptop or tablet scenario, it would either be my computer or his computer, and he says, look, let's look at women and girls, and then I would have to change it. It's a nice interaction when we are both in control. We're exploring more actively. So another benefit from using voice is that both participants are in control and can interact with the voice assistant. So I just want to summarize now is that I think you can design both chatbots and voice agents to elicit slow thinking. about their actions and their choices or conclusions they're making about data. And one of the main findings between voice and chatbot was that voice encourages more fluid conversations within the team, whereas the chatbot also slows down thinking, but it prompts, it requires more coordination between the team members to know when to read what's being said and how to interpret it. Overall, we found that using voice at the interface encouraged more exploration of the data. But I want to summarize by saying, let's not get carried away. Let's not design it so that these agents are always interrupting or making suggestions, because we do not want to end up like Microsoft's Clippy, which many of you who remember from those days tried to be helpful by suggesting that you wanted some help. So we have to be parsimonious when thinking about how to use these. And to do that, we need to decide on the criteria that will ensure proactivity is limited. So just to finally, my final takeaway is to think about, I've talked about fast and slow thinking, and I think we can design UX interaction mainly to support fast thinking, because that's desirable for many data viz tasks, particularly if we're trying to compare and make different selections. But we also want to think at opportune times to design the UX interaction to support slow thinking. And I think that can be good when users need to analyze data sets across multiple dimensions and not so that slows them down so they don't quickly jump to conclusions. Because as we know from Kahneman's book, there's a tendency to jump too quickly to conclusions. And I gave you that example of the bat and ball where we all jumped to the wrong conclusion. There is also a tendency to make errors or miss patterns and trends, and that's when getting someone just to step back and think might make them think differently. And when a team gets stuck in how to progress with their sense making, that's where having a prompt or a probe from an agent might help them. So just to summarize and finish, I think adding a chatbot or a voice assistant to software tools, particularly when you're doing data analysis, can be effective to scaffold that teamwork, to steer the conversation and to prompt reflection. And reflection is such an important part of our everyday cognition, and I think is really important to support. So finally, I'd just like to thank you all for listening. And if you have any questions, please let me know. And I'd like to thank my colleagues, Leon, Ethan, and Licha. Thank you.
Yeah, thank you very much for this very inspiring talk. We had more than 100 persons watching the Capstone. This very inspiring talk has also started a long discussion on YouTube, and now questions are coming in slowly after finishing the talk. So I would take them in the order how they are in the chat. So Wolfgang Eigner is asking a question about the Visi example, voice versus text interaction, whether you could elaborate a bit on the role of modalities and possibly a mixture of text and voice.
Yeah, I think that's a good question. I think this is one of, there's been a research into multimodality, but not in this context where you're carrying out another task. So it's already multimodal in that you're looking and interacting with the GUI, which is the data analytics tool. And what we want to know is what's the best way to add an agent. So it was really a first study, and we were able to find some differences between them. But I think there are many more ways in which we can think about how to design the interface. So you could have the users choose whether they wanted it to be voice or whether they wanted to use a chatbot. You could even, as was suggested, mix it up. So sometimes it could be you could give your commands to the agent in voice, and the agent could reply as a chatbot, or vice versa. So I think all of these are possible, and it requires more research to see what's the best for different types of tasks. You could even make it adaptive. So it could be that the agent thinks, this group is very talkative, we don't want to interrupt them. But occasionally we might want to steer them or guide them in a particular direction. And so they may use a chatbot. So I think the answer to that is we need more studies being conducted to look at these different aspects as to what would be optimal and also for what purpose. So as I said, for fast thinking, clearly GUIs are effective for this context. But for when you wanted to stop people and slow them down, having an agent make suggestions using voice can be perhaps an appropriate way.
Yeah, Petra Isenberg has a question that would be a kind of follow-up on that, and she asked, like, how do we determine which sense-making tasks are better for fast and which are better for slow thinking? And also Jason Dyke made an example of emergency management when really the decisions need to be very fast. Could you maybe say something on the type of task and situation?
Yeah, for the research we've been doing, it's open-ended, where you've got some data and you're trying to, like COVID-19, you've got all of this data coming in, you're trying to come up with the best action based on that will then inform policy, or you're trying to work out why it is over 30 years that we've got these increase in obesity levels. So for those types of open-ended, more slower tasks, then I think it's good to encourage at certain times slow interaction. But for emergency response, I totally agree. You don't want them to be sort of, looking and thinking, oh, maybe I should press this button or that one. Maybe that's what it means. When you've got a matter of seconds for life and death. But it could be that if there is a really important choice between A and B that could be life and death, and you've got 5 seconds to make it, then it might be good to just step back for a few seconds. So I don't think it's black and white. I can't say that these tasks it's good to do always fast thinking, and these tasks it's good to design an interface to encourage slow. I think what Kahneman says is that we always our instinct is to use fast thinking. We always jump to conclusions. What slow thinking tries to do is at certain times to slow you down and be more systematic. So I think if we want to encourage users to be more systematic for certain tasks, that's when we might design different aspects of the user interface for that. But it might be that you could sort of roughly say that there are certain tasks or aspects of certain tasks where certainly not slowing them down would be desirable. And I think I've tried to make that point in my talk, is that for most of the tasks, we're trying to speed up or to enable fast thinking, but there are certain times for a particular task when just stepping back and thinking it would be very useful and desirable. So again, it's a bit like, in human factors or ergonomics 30, 40 years ago, when there was thinking about task allocation, should we do the machine or the operator? You can think of it like that, but I think it's better to think about a task where you are supporting the user in the optimal way. Sometimes it can be fast and sometimes it can be slower. And that's how I think we should think of it.
Yeah, picking up on that, the next question, which is very, very popular on Discord, is about how to enable this slow thinking, depending on the device. The question is from Ms. Hong. Just to quote it, from my experiences, people may have different time spent expectations with different devices. For example, I may quickly slim on my phone while spending much more time with my computer. Do you think such design strategies make people slow down? Will be applicable for smaller screen visualizations?
Yes, I mean, that's a really good point about the type of device, whether it's small or very large. In our study, because we were looking at group work, we were interested in having a shared device. And therefore, we wanted them to be able to, all be able to look at it at the same time. But in terms of input, that was also a shared device, whether it was a speaker or a tablet. So I think it's really important as to the form factor of the device, as to how you interact with it. In terms of whether it slows you down more if you do it, say, on a smartphone or a tablet, I don't know the answer to that. But it obviously with a a tablet, you're able to see more than with a phone. So that example of the slow game that Willowdham came up with, all you could see was 4 or 5 LED lights, and it was just very simple, but it enabled you to think. When you look at some of those that game in 3D or virtual reality, it's much more complex, and you're very much in the game and you're immersed, and that may be that it makes it harder to think. So sometimes when it's the actual representations you're using are simple, that can trigger more slow thinking. So I think I would probably say that yes, the form factor of the device will have an effect on whether it encourages you to slow down. But as we know with our smartphones, we're only too quick to answer or to have a look if we get a notification. So smartphones encourage, I think, fast, or shall we say, very speedy thinking.
Here there is another question that goes also into the direction of how do we enable the slow thinking, which is from Louise Morais. Thank you very much for such an inspiring conversation. What are your next steps in exploring slow interactions? Do you have other interactions in mind besides text and voice?
No, actually. Part of the reason is because of the pandemic, I've had to work from home. And normally I have a lab where we build tangibles, we do tabletops, we work with the latest technologies, but I've not been allowed in for the last 18 months. So I've had to work with AI and chatbots and voice. And so what we're currently working on are different types of tasks. So Leon is currently working at trying to slow down people who are trading. So if you are on a platform, a software platform for trading, you might decide to sell or buy, and you might do it too quickly or too slowly. And he's designing a chatbot to encourage you to think a bit about, is that the right time to do that? We're also designing a chatbot to help people deal with scams and phishing online. So before you press that button to click and give away all your information and let them empty your bank account, we're trying to design chatbots to make you stop and slow down and just think a bit more before you do that. And another one we're doing is trying to encourage people to stop being too focused and to take a break. So we're designing a chatbot to encourage you to stop being sedentary, which in a way is getting you just to stop and move around and come back. So I think there's lots of ways in which you can design chatbots or voice assistants, and that's keeping me busy during the pandemic. But once we're back into the lab, we shall be designing other types of interfaces, particularly tangibles and physicalizations. And I can't wait to be able to start doing what I love most. But in the meantime, I'm looking at AI and chatbots and agents.
Well, there is another, thank you very, very much. There is another very popular question that came to my mind when you were talking about trading persons, experts, and that are used to certain devices and so need to think very, very fast. And the question is about the user and the psychological aspects of the user. Question is from Chatai, and the question is, have you looked into particular cognitive biases from decision-making psychology literature that may impact the reasoning process? Those biases would ideally be good candidates that can benefit from slow thinking.
Yes, that's what my PhD student Leon is looking at, is cognitive bias, and how might you get people to trigger some kind of metacognition, to step back and think, am I being biased here? Am I over, or am I making an error? Because these things, when we jump to conclusions, when we're thinking quickly on our feet, we resort to those kinds of steps that can trigger mistakes because we miss a step, and likewise with these different types of biases. So there's been lots written about biases, and to what extent we can manipulate or we can prevent these from happening, I think is for future research as to, they've been, specific ones have been identified in the lab, but we need to think about, do they happen? How do they manifest themselves in the real world? And how could we get people to be aware of them? So part of the research should be to think about increasing people's awareness of when they might be suspect to making a bias in their decisions, or when they might make an error, or when they are a little rash in making a decision. And I think many of us regret some of the decisions made because we've made them too quickly. So I think that is very much future research, is to think about what types of interfaces, So I've talked about chatbots and agents, but we could also think about wearables. So you might have a haptic device that could just sort of buzz you, or you could have some other kind of wearable that just increases your awareness of what you're about to do. And I think that's a really, would people after a while ignore that, or would they be, step back? So that's another thing, is habituation. Do we, habituate to these prompts and probes after a while? And that is something that we're starting to look at. How do we do research into that? So we have our work cut out in terms of thinking about taking this type of research, which has been traditionally done in psychology labs, now that we've got the technology that we can design, and taking it out into the world. So I think, as I said at the beginning of my talk, I've been working with health clinicians, and they say we've got loads and loads and loads and loads of data, and we've got all of these fancy data visualizations and tools, but really what we need is some help with how to do the interpretation, the analysis, and to be able to make sensible decisions or take actions. And so that's where we've come from, is to try and provide them with tools and support to help with that decision-making and analysis. And I think there are different ways in which we can do that. And I've just mentioned, what we're doing, but I think there are other ways too.
Yeah, thank you. There are many, many more questions about data and tasks, and I think we could spend here one more hour discussing things. I would like to continue on what you said about the biologists and interpreting data. There is a question that stems, I suppose, from the long discussion that I followed, was about how to, and the question is from Wolfgang Eigner, but there were many people discussing this, so the question is quite popular, is how do you sell slowing down users to a company that contracts with you with a visualization tool? Isn't it often about saving time and money that a tool should be introduced?
Absolutely, which is why I showed those slides at the beginning. That's how they sell their software. But I think just like AI is trying to now clean up its act by, reducing biases in the way in which the algorithms work, we could kind of think of a very different way in which we try and market data analytics by saying, the Tableau one about Ask Data, I think that's a start, where it's showing how you get the user to ask questions. Now, supposing you took that one step further and said, slow down and start thinking a bit, that you could try and get the marketing people to come up with slogans or ways of thinking about why slowing down is good. You could always get Daniel Kahneman to come along and support your product and endorse it. And that way, because he's such a well-known researcher, or that might be a starting point. What you don't want, though, is for Norman and Nielsen to start promoting slow UI based on that April Fool's blog. But I think, I don't know, I'm not a marketing person. I just believe in telling people, and trying to convince them through giving presentations, through writing, and through also showing them that you can improve, that, everyone knows they make mistakes. Everyone wishes that they had done something differently. If you can tap into that psychology in your marketing, then I'm sure you could start to encourage people to think, oh, this is quite a good thing to have as part of our package. So I've tried to say all along is that it's not don't go from fast to slow and everything slow, but to say at certain points, it's good to slow down. And I'm sure that there are some marketing people out there who would really help with how to package that up.
Dear Yvonne, thank you again for this wonderful talk. And thank you everyone for your thoughtful comments and questions. In the interest of time, I will stop the live discussion at this point, but please continue the discussion on Discord and Tobias. Thank you everyone, as well as the student volunteers and the technicians. And thank you, Yvonne, again.
Thank you very much.
Over.
Okay, thank you very much, Yvonne, for this great talk about new ways of rethinking of the user interface design and interaction aspects of visualization applications. So it's probably a general good idea to think about adopting some slower thinking in various situations during all these hectic times, and everything moves faster everywhere. Okay, thanks again for the keynote, for the Capstone talk. Thanks again to the programs chairs for inviting and leading the discussion. So we now can come back to the final words and notes on this conference, and we continue here with the next bits of information, statistics, and so on the conference and the programs. So we had all the workshops already closing, and for the main conference, just a recap before we hand over to the program chairs again quickly. We had 74 main contributions to the main EuroVis conference, tracks, 44 full papers, 20 short papers, 5-star, 5 posters, and a number of invited CGF papers in these different tracks. So actually one question that I had in mind and was looking forward is, has actually artificial intelligence and machine learning completely overtaken the visualization community? Well, not for the main EuroVis conference, at least. If you look at the papers, there were papers dealing with these topics, but if you look at artificial intelligence and machine learning, at least in the main titles of the papers, there were only 3 that had machine learning or neural network in the title and no paper with artificial intelligence. That doesn't mean that in the paper's content that was more on this topic, but it has not yet completely taken over our field. There are still a lot of traditional topics that more or less dominated still the main contributions from papers with analytics, graph, volume, multivariate, multidimensional visualization, or design in their titles. So moving on to some other statistics.
Exactly right. Thank you, Renato. So we have a lot more interesting information from YouTube about our viewing statistics. So as of this morning, we had about 7,800 views and a total watch time of 2,300 hours. And I'm sure this number has increased now with our beautiful Capstone presentation. The most watched videos are the opening and keynote, followed by the best papers, and then a good mixture of conference and workshop sessions. Those numbers have to be taken with a little grain of salt because the videos from earlier in this week had more time to be viewed. Nevertheless, we can clearly see how important the workshops are to the conference, as they often explore the new and upcoming topics that attract a lot of interest and attention. So according to YouTube, the audience consisted of 1/4 females and 3/4 of males. And we peaked around an age group of roughly the PhD students of around 25 to 34 years of age. So now I'm going to hand over to the program chairs for their closing remarks and the probably most anticipated part now, the remaining award ceremonies.
Hello everyone, I'm Liz Marai from University of Illinois at Chicago. I'm speaking as a papers chair at EuroVis this year, along with my co-chairs Rita Borgo at King's College London and Tatiana von Landesberger at University of Köln. This year, we award one Best Paper award and one honorable mention. In terms of the decision process, the chairs gave 5 candidate papers to the Best Paper Committee based on ratings and explicit Best Paper recommendations from reviewers. We are fortunate to have Kai Nieselt, Roxana Bujak, and Tim Dwyer serve on the Best Paper Committee. The committee made the final decision. The honorable mention goes to What Are Table Cartograms Good For Anyway? By Andrew McNutt. We quote from the Best Paper Committee. In proposing algebraic visualization analysis as a way to evaluate the effectiveness of visualizations, this paper lends a nice rigor to the problem of appraising effectiveness of specific visualization techniques against tasks. Although the method is demonstrated against a single visualization idiom, namely table cartograms, it is easy to see how it may be used as a general guide for future evaluations of other types of visualization. The Best Paper award goes to Color Nameability Predicts Inference Accuracy in Spatial Visualizations by Carrie Reda et al. We quote again from the Best Paper Committee. The paper provides valuable new results regarding quantitative color palettes and uses a clever and novel evaluation approach. The contributions are very clear and novel with potential impact across the whole field of visualization. It could even be said to challenge aspects of generally accepted visualization dogma, or to at least call for qualification of the simplistic statement that rainbow color maps are harmful. The study is objective and follows an interesting yet precise methodology with clear findings. In recognition of the importance of the review process, this year the full paper chairs instituted a Best Reviewer Award and an Honorable Reviewer Award. The Honorable Reviewer Award this year goes posthumously to Michel Westenberg. Michel completed his reviewing tasks with panache, timeliness, and generosity despite being severely ill. The inaugural Best Reviewer Award goes to Çağatay Turkay in recognition of his high-quality, timely, detailed, balanced, and thorough reviews. Thank you, and we hope everyone is safe and well.
Welcome to the ceremony for the Best Short Paper Award. I am Marco, and together with Christoph and Andreas, we will present this ceremony on behalf of the Best Short Paper Selection Committee. Before announcing the awards, we spend a few words about the selection process. First of all, the list of candidates was selected by short paper program co-chairs, according to the scores given by reviewers, their rationale, and with a constraint that at least one reviewer explicitly recommended the paper for the award. At the end of this process, we selected 4 candidates. After that, we nominated an independent committee composed by 3 well-known scholars in the community that we warmly thank for handling this selection process. They were in charge of performing an independent evaluation of the candidate papers and to discuss until reaching a consensus for selecting 1 honorable mention and 1 Best Short Paper Award. Starting from the honorable mention, the award goes to the paper Lost Contribution Based In Situ Visualization for Neural Network Training from Tang Yok Lee, with the following motivation.
There's a tremendous growth in the need for methods and techniques that help machine learning engineers understand and fine-tune their models. In this short paper, the authors describes a method that visualizes how the input training elements affect the loss of a deep learning model. The method is next deployed to show how to find difficult instances that contribute the most to the loss during training, and thus are prime candidates for additional training actions. The paper is elegant by its simplicity. The proposed methods can be easily replicated, being based on open source code, is fast, scalable, and can be generically applied to a wide class of deep learning problems. We believe that many researchers and practitioners will directly benefit from this visualization method when analyzing and aiming to improve their deep learning models.
Hello everyone, I'm Tinyoka Lee of Mitsubishi Electric. It's my great honor for the honorable mention. Thank you.
And finally, the best short paper goes to Analytic Ray Splitting for Controlled Precision Direct Volume Rendering by Sebastian Feist and Rudiger Westermann, with the following motivation.
As ray tracing methods become more popular for visualization algorithms, the expressiveness inherent in ray computation can produce superior results than traditional sampling methods. In this well-written short paper, Weiss and Westermann describe a post-classification DVR method to analytically split a ray producing piecewise cubic segments. These are evaluated within error bounds through Simpson quadrature. Examples are shown evaluating the method for error and speed with both synthetic and real-world data. Evaluations show better visual results with less error and without performance loss. The implementation is available on GitHub for replication of results.
Hello everyone, we are very honored to receive the Best Short Paper Award here at EuroVis 2021 and like to thank all the reviewers for the confidence in our research. We appreciate the effort the reviewers have spent reviewing our work and all the valuable suggestions they've raised.
So congratulations to the winner and see you at EuroVis 2022.
Here are now some more information on the Best Poster Award of the EuroVis 2021. We had 5 accepted posters this year, and all of them have been considered for the Best Poster Award. The decision on the best poster was made based on the review grades, on the 5 minutes video, on the poster itself, and on the discussions during the poster sessions with the poster authors. This was the best paper committee this year. We selected 3 excellent researchers from Visualization. We had Lonnie Besancon from the Linköping University, Johanna Bayer from the Harvard John A. Paulson School of Engineering and Applied Sciences, and Çağatay Türkay from the University of Warwick. We would like to thank the 3 very much for their time and for their careful selection of the best poster candidate this year. And now it's here, the exciting moment. So the Best Poster Award of EuroVis 2021 goes to Elastic Tree Layouts for Interactive Exploration of Mentorship by Xin-Yuan Yan and Yifang Ma. The poster presents a visualization technique to explore mentorship relationships. The proposed technique uses the screen space very efficiently, and the proposed use of elastic nodes and bands together with the interaction will be very useful for future developments. We very much congratulate the authors for winning this award. Congratulations from the poster chairs. Thanks for watching, and we are looking forward to an exciting poster session next year.
Congratulations to all the award winners. We now have a few more statistics for you. So you might remember from the registration process that you were asked which country you are from. And most attendees are coming from Germany, followed by the United States, by Austria, so the usual suspects. But then there are also many attendees from faraway places in South America and Africa and Asia who might not have had such an easy time to connect to us, to the conference, if it wasn't a virtual one. On the registration, we also asked how often you have attended EuroVis in the past. And as usual, a vast majority of attendees are newcomers to our community. And again, the virtual format seems to make it easier for us to attract new talent into our community. The virtual setup also requires us to communicate differently. And so we followed in the footsteps of last year's virtual conferences and used Discord. In total, we had more than 4,600 messages being sent throughout the week, with the most active users being Tim Gerritz, Jason Dyke, and Alexandra Diel, who initiated many interesting conversations. I'm now handing over to Renato, who is muted.
Yeah, thanks for the note. So now coming to some other aspects of the conference, we had a number of opportunities to virtually engage and socialize with other attendees, and the ones who took advantage of these highly appreciated these events. It's not an easy way to get people to interact in such a virtual setting, and we tried different forms and new forms, and hopefully at some point we will manage to get higher levels and get close to other scenarios that we were used to from before. We had online yoga, we had a virtual city tour of Zurich, we actually had visiting Rome virtually and introduction to next year's events. We met, took lunch and danced on Tobias. We played together some online games like Scribble or the city guessing game. We also successfully conducted the first EuroVis pub quiz, and maybe we can do this live in a pub in the near future. I, for my part, would be very happy to help with this and to organize this with future EuroVis conference chairs and organizers. Okay, and then we had a variety of discussions on Discord about pets, plants, football, and more. So thank you all for, especially the ones who participated and filled all these events with life. Without this, it would have been just empty and boring. And well, I just have to add this right now here. Obviously, we had one major event competing with EuroVis for this week. And we thank you for your attention despite this competition, and to prevent you from leaving right now to go to this other competitor and finish the closing session with you. So here just the current standing of the championship. So just wait a little bit before you switch to this other event back again. So, and with that, we out of our way, we can move on and go to thank a lot of people. And in particular, we want to thank, again, the people who were responsible for the scientific content, from soliciting, from reviewing to publishing it. So we have the program chairs. Thank you again. We had all the primary and secondary reviewers of the IPC and reviewer list. Thank you again as well. And we also have the people at Eurographics from the admin and the steering committee who helped us and supported us. We also have to thank the people organizing, planning, and running the show, the conference. We thank the local organizers for preparing everything. We thank the local technicians for controlling and running the streams based on all the training from Tobias. And we thank the student volunteers for their help and support with all the online systems, from session chats, from managing Discord channels, helping out with questions, and in the Tobias online world. Now, we also thank again at the end here to our sponsors that supported us. We have, again, the gold sponsor, Intel, silver sponsor, the Visual Computing Center. We have bronze sponsor, Tableau, and the academic sponsors, EuroVis, and organizational sponsors, Eurographics. Also, a reminder to check out the Eurographics subreddit part there. And obviously, our local institutions, University of Zurich, FAU Erlangen, and ETH Zurich, who supported us. And now, just for you, Tobias, from me personally, thank you for brilliantly taking over the lead with all the online conference preparation once we started to move to the virtual setup. Tobias was our organizational memory, without which we would have faced many last-minute crises, and he guaranteed a top-level technical setup. So very much appreciated, I think not only from me, but from all of us.
All right, thank you very much, Renato. It's all been a team effort, so it's all thanks to all of us organizing it together. I also wanted to thank all our attendees, of course, the virtual attendees who participated in the discussions in YouTube, in Discord, in Topia, to make this all a very active and lively conference.
So we hope to see you all real soon again, hopefully again in person, and hopefully also some people that cannot meet in person virtually, depending on the future setup of the conferences. But I do look forward to meeting people over lunch and in pubs in the evening. And with this, farewell from me and Tobias, and check out the last information of the upcoming visualization conferences.
With a big thanks to the organizers, I want to use this opportunity to promote the 26th International Symposium on Vision Modeling and Visualization, for short VMV, organized from Dresden, Germany. VMV is the annual symposium of the Computer Graphics Special Interest Group of the German Informatics Society. It is well established as Germany's premier scientific meeting that covers the full spectrum of visual computing. It is a unique event that brings together scientists and people interested in the interdisciplinary fields of computer graphics, computer vision, visualization, and visual analytics, with special emphasis on the link between the disciplines. Originally, we wanted to invite you to our computer graphics building, but now we have to do it online. The most important dates are the 25th of June, where the paper deadline is, and the 27th and 28th of September, where the symposium takes place. Please visit our website for more information. Publication will be through EuroGraphics Digital Library, and there will be selected papers going to the fast track of Computer Graphics Forum. We have 3 paper chairs for Vision, Björn Andres from Dresden, for Computer Graphics and Modeling, Marcel Kampen from Osnabrück, and for Visualization, Michael Sedelmeier from Stuttgart. The call for papers looks as usual, with modeling, rendering, visualization and interactive interfaces, computer vision and image processing, applications of visual computing, and here we want to focus a little bit on virtual and mixed reality. And we also want to point out our cross-domain topics like explainable AI, differential rendering, machine learning for modeling and visualization, and cross-domain aspects like energy efficiency, evaluation and perception, and benchmarking in datasets. Yeah, each chair has invited a speaker. Björn invited Xiu Tang. She will talk about pose estimation and tracking. Marcel invited Martin Marinov, and he will talk about recent work on generative design conversion to editable and watertight boundary representations. And Michael invited Tim Dwyer, who will talk about immersive analytics in a connected world. At the end, I want to invite you to think about how our research can help the future. Current trends like going open source or thinking about energy and memory efficiency are good. But you also have to think of how to use the user less and how to better make the society aware of current problems like climate change. And then, more importantly, we have to think about how to avoid dual use and rebound effects in order to come to a degrowth society. To discuss this is also a reason to come to VMV 2021. Thank you.
Hello everyone, we would like to invite you to attend VCBM 2021 this September. At VCBM, we cover the state-of-the-art in visual computing research with a strong focus on applications in biology and medicine. We place a particularly high focus on being an interdisciplinary forum for experts from research and the application in biology and medicine, so aim to be a place for both academics and practitioners. This year will already be the 11th edition after the past editions in Tübingen, Germany and Brno, Czech Republic, for example. Here's the conference URL for you to find out more. We currently plan VCBM as a hybrid event, so if the situation allows it, want to allow you to participate in person, but also want to allow remote attendance. The deadline for full and short papers is July 2nd. Posters and demos are due on August 18th, and the image contest has the deadline on September 12th. The proceedings are published by Eurographics as full open access. We also have exciting invited talks planned, one from visualization researcher Johanna Bayer from Harvard, and one from scientist, artist, and cultural theorist David Glowacki from the University of Bristol. Of course, in addition to coming for VCBM, while you are here, you could also visit Paris. We have some steampunky things. We have many museums with even older stuff, some of which you may have heard about already. Also museums with newer stuff. There's also very nice restaurants and even some churches that are still intact. And if you cannot come in person, which would be sad, then we also have some reasonable server hardware to accommodate you. So we hope to see you all at VCBM.
Hello, my name is Brian Suma, and Gustavo Renato and I are the General Chairs for Viz 2021. Viz 2021 will be October 24th through 29th. Due to the ongoing uncertainty over international travel, Viz 2021 will be virtual. We plan to improve on the experience of last year's Viz, which saw a record number of attendees. We will have an exciting program full of innovative technical presentations, competitions, and Viz applications, along with stimulating associated events. Viz will also have a large set of interesting workshops that will run during the conference. Follow this QR code for more details. While we are virtual, we know that there are valuable experiences that can only happen in person. We are excited to announce the Viz 2021 Satellite Program. This program will support local and regional in-person gatherings that can be done safely. Each satellite will be an official IEEE event and will have a unique supplemental program. Follow the QR code for more information, and I invite you to become a local chair for Viz 2021. Even though we'll be apart, we'll still be together. Gustavo and I are honored to be the General Chairs for Viz 2021, the first unified Viz conference. We hope to see you all virtually, or at one of our in-person satellite events this fall. Have a great summer.
Hello, my name is Kazuo Misue. I'm a professor at the University of Tsukuba, Japan. I have been appointed the conference chair of Pacific Viz 2022. Next Pacific Viz is 15th time. Date is scheduled for April 11 to 14th, 2022. The venue is Tsukuba Science City in Japan, or virtual online, depending on the situation of COVID-19. The details of the symposium have not been decided yet, but we'll prepare some paper categories: full papers, visualization notes, so-called short papers, and posters. 1 or 2 workshops will be added. We'll announce details on the web page as soon as they are decided. Tsukuba City is an academic city with many research institutes in addition to the University of Tsukuba. It is about 50 kilometers from Tokyo. By using Tsukuba Express, an express railway, it is possible to come from Tokyo in 45 minutes. By the way, the terminal on the Tokyo side of Tsukuba Express is Akihabara. Akihabara is famous as an electric town, but some of you may know it as a town of anime, comics, and maid cafe. I'm looking forward to seeing you in Tsukuba I hope you enjoy Pacific Beach, Tsukuba City, and Japan. Thank you.
Good morning to everybody. I am Giuseppe Santucci, and I am very excited to give you some pieces of information about the new edition of EuroVis in Rome. 2 W's. First of all, when? The conference will take place between 13 and 17 of June. And please be aware that the week before, the conference ADI 2022 will take place in Rome, very close to Rome. That represents a synergy, in my opinion, and likely some of you will take advantage of this. Second W, who? Conference chair. Me, Tiziana Catarci, and Marco Scherf, two colleagues of mine, and we represent the old people taking the credit. And who will do the real job? Young people. From my research group, however, Marco Angelini, Simone Lenti, Graziano Basildi, Alessio Paleschi. They will do the real stuff. 2 quick words about the research group. We do research on visualization by more or less 20 years, dealing with both theoretical aspects, like visual quality metrics, progressive visual analytics, and so on, and applying them to real fields, like information retrieval, cybersecurity, network medicine, and so on. Let's go to the third W, where we are going to have the conference in the Pontifical University of Thomas Aquinas. I will call it Angelicum for short in the following. And it is located exactly in the center of Rome, here. It is really old, and it started in 1200 more or less in Rome. Now it is more modern, of course, but still preserving the charm of that old teaching. And what about accommodation? We have a lot of hotel around Angelicum. Angelicum is not an hotel, but Rome is full of them, so no problem about that. And most of them are in walking distance. And if you want to do some exercise, we have a lot of nice place around the conference center to walk to. So enjoy yourself around. And what about the social event? We are still making a decision between Acquario Romano Garden, the beautiful building, and the historical Domus Circo Massimo. We will make soon a decision about that. And remember, there are a lot of other scientific facilities around, so you will have time to enjoy yourself everywhere in Rome, you know. And having said that, I think that you have no excuses anymore. Come in Rome for EuroVis 2022. Here there is a website link with the updated information day by day, and eventually we will have a Vis-a-Vis conference.